Okay. Hello. Okay. So the answer for number 10, we're on section 3.5 and we're going over the homework. Number 10 is feet per minute. So just on these problems, all you needed to do was do the unit analysis. That's all you needed to do. And number 12 is miles per minute. Miles per minute. When I say the word per, what am I meaning? What punctuation in math are you using, Peter? Yeah, divided by. You should have that division sign, okay? All right. Any questions on 9 through 12 right there?
Wait, can you repeat it out of here? I was getting my brother.
Okay. You can get it in a minute. You'll get it from John, okay? But don't not listen to these ones, okay? And now we have 14. Okay, and you drew a diagram of that cover. So the worksheet that I gave you yesterday that had the cover with, you know, the pictures on it and then the spaces in between it and the margins, that's what you should have drawn for 14, okay? Number 16 is 2 1/4 is the answer, and each picture should be 2 1/4 inches wide, okay?
How about 2.25?
Is that the same as 2 1/4?
Yes.
It is. 2.25 is the same. That's a fine answer, okay? All right, and then we have 18. And this problem I did on the video for you. I did 18, 19, and 20. So it's this little elephant. He's at the watering hole. He's chilling out. And all of a sudden he realizes that his whole herd has left him behind, okay? So for 18, the answer is 1/12 of an hour. And let's just talk about that real quick. It was 5 minutes. 5 minutes is what of an hour? How do you write that, and how do you know that? Javi?
Something out of 60.
It's something out of 60. It's 5 minutes out of 60, so what does that reduce to? 1/12, okay? And then for that time, it was 5/6 of a mile. That's the second part to that answer, 5/6. John, what do you need?
I just want to say I think the elephant was actually being lazy and actually fell asleep.
Really?
While his troop, like I'm pretty sure he was told that the day before, but then he slept in.
Okay. I don't know. I figured he might have wanted to be getting some more water for the watering hole. All right, ready, everybody? Let's do it. Number 20. So number 20, the answer for that looks something like this, okay? It should be x plus 1/2 equals 5/6. The total miles that elephant ran to catch up, I believe, was 5/6 of a mile. And then the x plus 1/2 represents the herd distance, the distance that the herd is moving, okay? And x is representing the herd distance while he is staying still, okay? You can look at all of that on the video. Okay, the next one is the rabbit one. And the rabbit and the coyote. So let's look at answer 24. Actually, I've been informed, and I might need to be informed again, okay, that this is the challenge. So you actually need 23 as the answer too. So the answer to 23 is the rabbit is 1.2 seconds, okay? That's how long I believe it's taking the rabbit to get to its hole, okay, 1.2 seconds. And then the coyote is going to be a little bit different. He has, if it's a distance, let's see, he's going to be x plus 30 over 50 seconds, x plus 30 over 50, okay? Let me give you the answer to 24. And that is going to be when those two things are equal to each other, we're setting the fox and the rabbit equal to each other, okay? So x plus 30 over 50 equals the 1.2, okay? So that's the time. And the answer is going to be 30 feet for that. And number 25, okay, number 25. If the coyote is 30 feet from the rabbit and the coyote are going to reach the burrow at the same time, okay? If x is less than 30 feet, not a good scenario for the rabbit, okay? If X is less than 30 feet, the coyote is gonna get to the rabbit first before he gets to the hole, okay? If X is greater than 30 feet, the rabbit should be able to escape and be fine, okay? I think what I'm gonna do is put that one on a video. Either I'll come in tomorrow and do it for you, put it on a video. I have so many notes and I transferred my equations so many different ways. I just would rather do that later. Because in all humility, I kind of went blank in the last class on that, as I told them. So, I mean, I just looked at it a minute ago. I'm doing it fine. I see actually what I did on one part, but I'm going to just wait because I don't want to bounce into that syndrome again. So let's look at this next section, okay? And the next section is 3.6. And it's a section, hello again. It's a section where things just don't work out very perfectly. Like my brain cramp this morning when I was looking at my own notes on something, okay? Like, what did I do? All right. But that's okay. That's really kind of just part of life, to be honest. And now I have to find my examples for this. Okay, so here's 3.6. So everything in 3.6 is just not working out very perfectly. How many of you know that in scientists, you know, when you're doing experiments with Mr. Hoffman or Mrs. Salas or whatever you're doing, you're going to just get these nice little perfect answers that work out to be, you know, X is 5 or stuff like what we normally get in class. You're just going to get answers that go on forever, you know. You're going to have plenty of numbers that are repeating decimals or non-repeating decimals, whatever it may be. So we're going to go into that world a little bit today, okay? So 3.6 is solving equations with decimals. Let's check that out. Solving decimal equations. Okay. Let's look at a first example and say, so here's a real life scenario. Say you're sharing a house with, well, I guess you wouldn't share a phone with roommates. Let's just say this is your parents' phone bill, and they decide that they're going to let you stay on that bill for a while, okay, as you get older. And the bill is $58.25. But one day they decide to kick you out of the nest, and they say, hey, this chump needs to start paying, okay? So now we've got to pay for our own phone bill, okay? And let's say that there's 4 of you on that phone bill. What's an equation to find out how much each of you needs to pay? And by the way, we're not doing it like, oh, you talk more, you have to pay more, or whatever, okay? How do I do this, Matthew?
58.25 divided by 4.
Okay, sure. So each person is going to pay 58.25 divided by 4. And have you pulled out your calculators? I didn't mention that. You need your calculators today. Let's pull those out, okay? Ben's pointing to his brain. Okay, Ben. But unfortunately, sometimes you have an error message that comes through, and I trust you in class, and then I'm like, wait a minute, that was wrong. I just write down what you say. That's so funny. Okay, here we go. 58.25 divided by 4. What do we have?
4.5.
Yep, we get 14. Okay, so this is money. 14,562 something or other. So now this is money. So we have to be reasonable about this. Where are we going to round this to?
60.
I'm going to round it to this, to the hundredths place, because that's the nearest penny. Okay, so we're going to round this to approximately 14.56. Okay, each person's going to pay that. Now, let's go ahead and just check your answer. So on your quiz, I told you all, I said, hey, plug those answers back in that you did, and you're going to see if you got the right answer on the test. That makes sense? Plug this back into your calculator, multiply this times 4, and see what you get. What do you get?
58.25.
58.24. So we're shy a penny on that bill. The bill has to be paid, so you're gonna pay the company the 2.5. So this is not a perfect scenario. So when you plug the answers back in, when we approximate like this, your answers aren't going to come out perfectly, okay? Someone else has to up the ante and pay 1 extra penny for the bill, okay? All right, example 2. Here's 1. Okay. Now, for example 2, let's see, how about this? 26x minus 32 equals 99. Tell me what I need to do with that minus 32.
Add it.
Add it to both sides? Okay, so if I add it here, what happens? It's gone. It's gone. I have 26x. And now I have 99 plus 32. Somebody give that to me, please. What is it? Okay, and now what do I need to do? Divide both sides by 26. Let's do it. Please do that on your calculator and let's see what we get. You're going to be given the instructions. So on this one, we're going to round to the nearest hundredths place. Okay, so you have to be given some instructions. So if it's money, we're going to round to the nearest penny. In this case, we're rounding to the nearest hundredths. What you got, John?
5.04.
Okay, so you had 0.38 something, right?
Yeah.
Okay, so he rounded to the nearest hundredths place and got 5.04, okay? And that's fine. What happens if we plug that one back in? Put that in your calculator, please. 5.04, multiply it times 26, and then subtract 32, and tell me what you get. You get 99.4? 0.04. Okay, so you can see, again, do not expect to get the exact answers when you're rounding something like this. Right? Okay. Peter? Okay. All right. Number 3. Okay. How about this one? 9.92 x minus 6.13 equals 5.96 minus 7.28x. Let me look at these numbers, make sure I wrote them right. Okay, looks good. What do I need to do? Javi?
Add 7.828x to the other side.
Sure, we need to add that to both sides. Okay, so if I add it here, does it disappear? It's gone. It's gone. You know what, for the sake of just all the complication with these decimals this time, I'm gonna do the old method. And I would like someone to find this for me. Please, tell me what that is.
16.
I don't think so. Something's wrong with that calculator.
264.
17.20.
Oh, we're adding them. Huh?
Yeah. All right, here we go, Mr. Ben. Get that calculator, get that error message out of there, right? Here we go. What do I need to do on this side?
Add it to both sides.
Add it. Yes? Add it?
Yes.
Okay, add it to both sides. Let's do it. I'm going to write it underneath again this time. And I'd like someone to help me here. Is this same sign sum or is it different signs different? What is?
Same sign.
It is. So sum them. Add them. Go for it. What do you got?
12.09.
Okay. I like that.
12 points.
There it is. And now what do I do to solve this equation? Yeah, let's divide both sides by 17 and 2/10. 17.2. Okay, go ahead and do that for me, please, and let's see what you get. It's going to be an approximate answer. And on this problem, we're going to round it to the nearest hundredths. 0.7? Okay, I'm gonna write a little bit more than that first, because I want us to realize, here it is. It says round to the nearest hundredths, right, Hobby? So I'm gonna have 70 there, okay? Of course, that's 0.7 or 7/10, but they're asking me to round to the hundredths place, so I'm gonna leave that there. Any questions about this problem? No? Okay. Example 3. That was 3. Did I ever change it to 3? Did you write 3 on your papers?
Yes.
Awesome. Here we go. I'm going to do this one a little bit differently.
Are we going to be able to use calculators on our homework?
Yes. Okay. 3.7 minus 2.5 equals 6.1x minus 12.2. Round it to the nearest tenth is the instruction. The tenths place. Let me see if I wrote it right, and that would be a good idea for you to check too. So 3.7. Okay, it looks good to me. You know what? I'm going to do this differently than I have it on the paper, because I think I'd like to get it. I'd like to wipe out the decimals. Let's wipe these out. How can I wipe these decimals out completely from this equation? You haven't seen me do this before, but I think you've probably done this. Miss Camilla, I could multiply both sides by 10. Let's do it. So I'm going to put a 10 in front of here, and we're going to use the distributive property to multiply. So what is 10 times 3.7x?
0.37.
It's Ben, I'm listening. It's 37. It's just 37x. Yeah. Whoops. Okay, 10 times this makes it 37, right? And you could do that multiplication if you need to prove it to yourself. Do it. But 10 times this is what?
25.
Minus the 25 equals 10 times this is 61. And 10 times this is?
122.
Yep, negative 122.
61x.
X, yes, absolutely. Don't drop that X. Okay, all right. Let's go ahead. Let's do a left-handed layup here. Do you notice, do you notice that I can, if I subtract this from both sides, I'm gonna bring it over here this time, just so I can keep it positive. That's what I'll do, okay? So let's take 37 away from both sides. I'm left with 0 minus 25. Tell me what this is. Is that same sign sum or different signs difference?
Different signs.
It is. And tell me what this is.
I think it's going to be 23.
Is it positive
24.
23 or 24?
24.
It's 24. Is it positive or negative? It's positive. The larger number is positive. So here it is. It's 24x minus that 122. Okay. And now I'm going to bring this over here. Yes? And it's going to become positive, right? Is this same sign sum or different signs difference?
Different signs different.
It is. So subtract them and tell me what you got. 97? Positive or negative? Why negative?
Sorry, positive.
Positive. The larger number is positive, so on that number line, it's 0 down to 25, and then it's up 122 over this way. It's positive. Okay? All right, 97 equals 24x. Please use your calculators. Divide by 24, and the instructions said to round to the nearest tenths. Let's do it. Tell me what you get. Okay, so give me a little bit. Before we round it to the tenths, what do you have? 041, thank you. And we're going to round it to the tenths place. What number is in the tenths place?
The full 0.
The 0 is. And what happens? It stays, okay? That's your answer. Last example. Here we go. You might even get a little dance at the end of this example,
Yes.
Yes.
okay? Because I have something that you really need to pay attention to at the end of this example. Okay, guys, mostly guys and a few gals. You're going out, guess what you're doing? You are buying a necklace for your sweetheart, okay? And guess what? You have to get her a necklace to match her earrings. But guess how much money you have?
$5.
You're in ninth grade. Guess how much you have? This is how much money you've got to spend. Listen, it's not going to be a very nice necklace, but it's the thought that counts, and trust me, they're going to appreciate this,
Like
okay?
one of those plastic bowls.
Oh, yeah, the one that you get.
Okay, shh, ready? Here we go. The tax on this necklace is going to be, this is the total money in your pocket, by the way.
That's a lot. I wouldn't mark that.
Rich boy.
The tax rate.
Oh, you have to worry about taxes.
Are you guys ready? Are you ready to come back? Come back. Come back. Thank you. Come back. All right. So you've got this much in your pocket. The tax for the necklace is going to be 6%. So you have a certain price limit that you can spend on this necklace. You don't know what it is. Okay? And we're for the necklace. You're going to spend that money, and then you're going to find the tax on that. Basically, I could just call this the cost of the necklace, right? So the cost of the necklace plus the what?
Tax.
Thank you. Plus the tax is equal to what? The total. So how do we find the tax? We take the rate, right? Which is 6%. How do you change that to a decimal?
0.6.
Point what?
Point.
0.06, okay? So we're dividing it by 100. It could be 6 over 100 or 6/100ths, like that. So the rate of the tax. Now, to find a tax, do I add, subtract, or multiply or divide it
Divide.
times the price?
Divide it times.
Oh, Ben. What do you do? Everybody say that really loud. Multiply, because Ben said that, and I don't want people in the video being like, do what he did. Okay, everybody's gonna multiply, right? You're gonna multiply it times the cost of the necklace, okay? So that's the price limit that we have. Okay. I guess I'm a little bit boring about this right now, because in the last class, I drew a pretty little necklace, so I'll draw one for you guys, okay? So here's your necklace. It's lovely, okay? There's some gems on it. That's gonna equal our total. What, by the way, is the total?
21.25.
That's what you've got to spend, $21.25. What is the cost of the necklace? We don't know. X.
$22.
Okay, shh, stay with me.
Sorry.
Stay with me. Here's X. This is what it is. And now I'm gonna find the tax for the necklace. It's going to be 0.06 times the price of the necklace. That's our X. Equals this. So what is X plus 0.06X? You have to be careful about this. X is really 1X, isn't it?
Yes.
But I'm adding 0.06X to it. So you have to remember 1X is 1.00X. What is that when you add it up? Yeah. Please don't make an error with that. I could see some errors happening right there. Okay? All right, so it's 1.06X equals 21.25. What are we going to do to both sides? Divide it. Go ahead and use your calculator, please, and divide that.
Give me a second.
What do you have?
I can't see it. But I'm stencil away.
What is it? 21? No, $20. What? 0.047. This is money. So guess what? You usually do what?
Money sign.
You round to the nearest what? Penny, which is the hundredths place. I'll underline that hundredths place. The 4 is in there.
Yes.
Okay, are you ready? Are you ready?
Yes.
Peter didn't even see me. Come on, guys. Listen, why am I jumping up and down? Because I love to act like a fool in front of a bunch of ninth graders. No. Why? What's the problem? Am I allowed to round this money up?
Yes. Yes.
No.
No.
If I round this up to 5, you only have $21.25 in your pocket.
Tip.
If I round this up, you will not be able to buy the necklace. This is the price limit for the necklace. So you can't go above this. You can't go above that price. So you have to, it has to stop at $20.04. That's the price of the necklace. You can't even have that one extra penny, or you're going to be begging from the person behind you in line to give you a penny. Okay? Either that, or you'll start go working the job and you'll be like, okay, I'm going to go clean up whatever, so you give me a penny. The bottom line is, whoever this girl is going to be pretty happy that you thought about her.
Oh, it's not a girl.
Okay. Chill. Lord have mercy. Okay, buy a necklace for your dog. I don't know. Okay. They do. You know, people have like rhinestone collars for the dogs. Okay. All right. So that's it. Guess what? You can start your homework. I need to pass out a lot of papers to you. And guess what you need to show me? 3-point what?
5.
Yeah. 4 and 5, I think, for you.
Yeah, I got it.